So today we're going to go ahead and start with our beautiful circles in standard form. More particularly, we're going to go ahead and see the situations that happen when you have a circle on a coordinate plane. Okay. Now we're going to go ahead and learn how to write the equation of a circle in standard form with the given information, center, and a radius. Okay. So go ahead, do the best. Everybody has this. So we're going to go ahead and write equations of a circle, given information. Now, let's go ahead and first introduce how do we have all this here? ¿Qué pasó? Yeah. Okay. All right. So now I want you guys to copy down the definition of a circle according to what it's given in a coordinate plane. So a circle basically is a set of all points in a plane that are equidistant from a given point. We're going to go ahead and call that a center. Now, guys, pause. We have a set of all points in a plane that are equidistant from a given point called the center. Now, there's a specific equation that we're going to go ahead and use. And it's this one down below, guys. It might look a little intimidating. However, I'll go ahead and explain the parts in a second, okay? But we do know what a beautiful circle looks like. We're going to have a center, we're going to have a radius, and we're going to sometimes have a diameter. However, we know that diameter is the entire chord that goes to the center, and the radius can be found by just taking half of that beautiful length. Now, non-examples, we have a quadratic formula, guys, or a beautiful square. We know that a square is not a circle, okay? Everybody has this? Yeah? No? Yeah, okay. All right, so a beautiful circle. We're going to go ahead and look at all the points on plane that are equidistant from a point called the circle. Now, how in the world do we graph all those points? Well, we're going to go ahead and analyze all the points that are existing in our y direction and our x direction, and from that point, find all those particular points that are the same distance away from that center. So here is an image you guys can see of a circle. I have my beautiful radius that is existing from the center all the way to the end of the circle, right? If I were to construct infinitely many radius or radii, I am able to plot all the endpoints from not the center, but away from the center at the other extreme of that radius. That will then create that beautiful circle all around, right? Now, how do I find the measurement of the radius? Well, sometimes it's going to be given, sometimes it's not. And if it's not given, we're going to go ahead and try to create a right triangle given from one extreme on the circle and the other extreme being the center. And once we create a beautiful right triangle, we can go ahead and find that distance. What do we call that distance from a right triangle? Do you guys remember? It's the radius, but from a triangle, the right triangle. We had a leg, another leg, and a hypotenuse. So we're going to go ahead and use our beautiful right triangle formula, guys. Do you guys remember what it looks like? Do you guys remember? A squared plus B squared equals C squared. Well, our friend is coming back to the picture, and we're going to go ahead and figure out how to find this beautiful length, C, given the circle, given the radius. Now, we're going to go ahead and use the Pythagorean theorem to find what that length is, and then from there, find each of the parts, right? Now, one leg and the other leg, guys, we're going to go ahead and use the distance formula, and the distance is going to be given right here. Our distance is going to be from my center all the way to a point on my beautiful circle, and I'm able to create that beautiful figure. So let me go ahead and draw it so you guys can see it. Let's say that this is my circle. Here is my center. And I'm able to create those parts, right? So I'm able to see where exactly that beautiful circle goes and is figured out. So I'm going to go ahead and create that beautiful triangle. and find what that distance is. Now, the distance in this case, we're going to go ahead and see that it's made out of the distances from our x value and our y value, or an x direction, y direction. So from here to here, we have our x1 and our x2. From here to here, notice here that we have our y1 and our y2. So remember that this is a leg, and this is another leg. We're going to go ahead and use those two parts to figure out where exactly my distances are, okay? So that brings us up now to the equation of a circle. Instead of using the x1, x2, we're going to go ahead and use hk as our center, and the other existing point that is perpendicular to the point existing on the circle as k, x and k, and the other point as x and y. And we're going to go ahead and figure out what the equation is. So with that said, let's go ahead and copy this one down. Standard form of the equation of a circle. We're going to go ahead and have something in our x direction, which is our h. We're going to have something given in our y direction, which is our beautiful k. And that distance that we have in the circle is going to be our beautiful radius squared, okay? So I can derive with the equation. Notice here that I have my a. This is my a squared plus b squared equals c squared. Here's my radius. Here's my a. Here's my b. Here's that c. So I'm going to go ahead and use that Pythagorean theorem so I can go ahead and write my equation of a circle. So that's where it comes from, okay? It doesn't just magically appear from magic land. It actually comes from the Pythagorean theorem, and then from there we're able to graph all of the parts that are equidistant from the center all the way to the end of the circle. So x minus h squared plus y minus k squared equals r squared. Now, what is h, what is k, and what is r representing here? You can go ahead and see the picture on the side, and you'll be able to identify that my center is what? My h and my k. So I'm going to go ahead and write that down. Make a note, guys. My h is the x component of my beautiful center. My k is the y component of the center. So they don't just magically appear out of nowhere. If we're given a center, we're going to go ahead and make it as an h and a k. So this is my x component, x coordinate. And this is my y coordinate of the center. And what is the r? R is going to be my radius. That's my beautiful hypotenuse. That's what I have given to me, or I will have to find out what it is, depending on what my information is given or what the equation or not the equation, the question is asking for. Okay, listos. Everybody has this? Yeah? All right. H and K. So x minus h squared plus y minus k squared equals r squared. All right, so let's go ahead and go into our first example. Write the equation of a circle. We're given the center, -3, 2, and the radius of 4. So write the equation of a circle with the center, -3, 2, and the radius 4. All right. So first things first, what does the standard equation of a circle look like? Armando, pass it on. Lauren?
No. Juan.
Juan, a ver, Juan, what's the standard equation of a circle? We just wrote it down.
Well, x minus h,
X minus H
squared,
squared.
plus, y
Y.
minus k squared equal R2.
R squared, there you go. So we have our standard equation of a circle. Now, the only parts that we're going to go ahead and substitute, guys, are the variables that are present as h, k, and r. So here is beautiful h, here is beautiful k, and here is beautiful r. Now, whenever we're given a center, we said that our center is going to be represented by H and K. So what is our center? What's our center, guys? -3 and 2. We're also given the information of our beautiful radius. What is my radius? 4. So that means that r is going to equal 4. Now, using the equation that we were just given, we're going to go ahead and substitute the parts. So I'm going to write x minus, instead of writing h, I'm not going to write h anymore. I'm going to write the h component of my beautiful circle, which is what? What is it, guys? I'm circling it. -3. So I'm going to write -3 in my equation. -3 plus y minus my k component of my beautiful center, which is what? 2. There you go. 2. Let me go ahead and write that down. And squared equals my radius to the power of 2. So I'm going to write radius, which is r, which is 4, to the power of beautiful 2. All right, let me go ahead and simplify it one more time, just because I don't like to see my negative and negative. So I have x minus -3, it becomes a +3 squared plus y minus 2 squared equals 4 squared is beautiful 16. And there you go. I'm able to write the beautiful equation of a circle that has a center at -3, 2, and the radius of 4. Not too bad, right? Pretty straightforward. Okay, let me go ahead and save an image. Everybody has this. Okay. Let's go ahead and do one more. Let me go ahead and clear. Go ahead and copy this one down. Write the equation of a circle with the center at 1, -4, and radius of 2. All right. Lauren, pass it on. You went last? Who was it? That's right. Juan, you were last. Pass it on.
Ready?
Riley, back to Riley. All right, Riley. What's the standard equation of a circle?
X minus h squared plus y minus k squared equals r squared.
Equals r squared. So think about the Pythagorean theorem, guys. And very similarly, instead of a, we have now x minus h. Instead of b, we have y minus k. And instead of c, we now have r, right? So let's go ahead and identify our beautiful parts. Do I have a center? Yes, I do. So my center is going to represent or be represented by h and k. My radius is going to be representing r. So in this case, my radius is going to equal 2. So what do I write as my beautiful equation? X minus what? What's my h component? H is 1 and k is -4. So let's go ahead and write 1 for h squared plus y minus k in this case is -4 squared equals r squared, which is 2 squared. All right. X minus 1, let's go ahead and simplify one more time. Plus y minus -4 becomes a positive 4 squared equals 4. And there you go. How do you feel about these? Not too bad, right? You ready to try one on your own? I think so. I hope so. Okay, everybody has this?
Yes.
All right, let me go ahead and clear. Go ahead and try this one on your own, guys. Number 3. Write the equation of a circle with a center at 8, 9, and radius of 10. Let's see what you guys got. I'll give you guys about one. Which one? All right, friend. So what is our beautiful standard equation of a circle?
The X minus H squared plus Y minus K squared equals R squared.
Equals r squared. All right, let's go ahead and identify our parts. We need 3 things. We need an H, we need a K, and we need a beautiful R. Brandon, pass it on. Derek, so what's my H, my K, and my R?
I think that
8 is what?
H is
H is 8. Okay. Nine and R 10. There you go. All right, let's see how it looks like in my beautiful equation. Derek, pass it on. Anybody? I bet Gabriel. What would my equation look like now?
squared plus Y minus 9 squared equals 100.
10 squared, and then one more step, it becomes 100. So x minus 8 squared plus 9, y minus 9 squared equals 100. And we're able to identify all these parts. Okay, now this is writing my beautiful equation in standard form. We're able to identify our h, our k, and our beautiful radius. Now, what would happen if I were to be given the information in a different way? Let's go ahead and see what happens. Okay, so here we go. Determine the center, radius, and equation of the beautiful circle. Now, what if you were to be given the graph instead of the beautiful parts? What would we do? Well, we have a circle. We know that it has the parts that we need. So I'm gonna go and write my beautiful equation first. Let's see. I need x minus h squared plus y minus k squared and my radius squared. What 3 things do I need to write the equation? I need what? I need the x component of my beautiful center. I need the y component of my beautiful center. And I need what else? The radius, those 3 things. So I need my beautiful center. I need a center at HK. And I need my beautiful radius. So let's go ahead and find that out from the image. What is the center of this beautiful image?
0.
It's at the origin, 0, 0. So sometimes it's going to be given, sometimes it's not, but we can go ahead and identify it by its beautiful parts. So my center, from looking at the image, it's going to be at 0, 0. So we have our center. Now, how about the radius? What did we define a radius to be? It's going to be from the center all the way to the end of the circle. So we can go either horizontally, we can go vertically, we can go the other way horizontally, or we can go the other way vertically. All we have to do is find the distance from the center all the way to the end of the circle. So in this case, it's going by 1. So 1, 2, 3, 4, 5. We can go ahead and count the units. So how many units from the center all the way to the end? 1 and beautiful 2. So this is 2 units. So therefore my radius is 2. Let's go ahead and write the equation now, given the parts and looking at the image. So we have x minus, if it's 0, we're going to go ahead and write 0 squared plus y minus 0 squared equals our beautiful radius squared. Remember that this is my center, and my beautiful radius. So what is x minus 0? Let's simplify that part. X. So x squared. Y minus 0. Y. So y squared equals 2 squared. It would be beautiful 4. So therefore, we're able to see that we have an equation at x squared plus y squared equals 4 in this case. Woohoo! Not too bad, right? Okay, let's go ahead and save an image. Everybody has this? No? Okay. Let me know if I'm going too fast, guys. Okay, I'm already going to clear it. Okay, how about this one? Determine the center, radius, and equation of this beautiful circle. I'll let you guys copy this one down so you guys can have it. So determine the radius, the center radius and equation of the circle. Go ahead and analyze it, study it, guys. Look at the parts, look at the image. We have to find those 3 things, the center, the radius, and the equation of the beautiful circle. Kenny's ready, right? You ready? Listo? A ver, Kenny, what's the standard equation of the beautiful circle? In standard form. Yep.
Isn't it? X minus 8, the second power, or 8. A2 plus B2 equals 2. Is that?
But in a circle. We need the h and the k.
Okay, so y, I mean, k equals minus x, what is it?
X minus h squared.
Is it k?
This one is a y minus k equals r squared. All right. So again, we need those 3 things. We need the x component of a center, we need the y component of the center, and we need our beautiful radius. Kenny, pass it on.
No,
A ver, Jorgito. So what is our beautiful center?
there's 1, 4,
It's close.
4.
It's 4, 1. We always look at our x component first and then the y component. So we have it at positive 4, positive 1. What is the radius? Jorge, pass it on. All right, Soleil, what's my beautiful radius? How do we find the radius? From the center all the way to the end of a circle. Let's see, let's count the units. 1, 2, 3, 4, and 5. You're close, so it's 5 in this case. So my R is going to equal 5. Now that we have those units, we can go ahead and find what the equation is. Soleil, pass it on. Fernando, how do I write my beautiful equation?
X minus 4
Okay,
squared plus y minus 1 equal 5 squared.
equals 5 squared. We're gonna go ahead and simplify x minus 4 squared plus y minus 1 squared equals 25. And there you go. We're able to write the equation of a beautiful circle. How do you feel about these so far, guys? Not too bad? Okay. All right, let me go ahead and give you guys your exit ticket so you guys can show me that you guys were able to understand all of this. And I'll give you guys access to your beautiful homework.